আটকালে তো অনেক কম হবে না, এটা কম হবে। কিন্তু এটা চিন্তা হবে, এটা মেন হচ্ছে এইটা এই বেলাটা চিন্তা হবে। হয়েছে কোনটা চেঞ্জ এটা এখন এটা দেখছি হলো এটা তো স্যার এই আগেরটা তো বেশি হলো না, এটা 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 দেখে গেছে মোটামুটি এইটা দেখা জানা হয়ে গেছে। এটা ফিটিংটাই তো হয়েছে ঠিক মতো।
Hello. Hi. Good evening, everyone. I hope my audio is visible, video is visible, and I'm audible. So, good evening, everyone, and welcome to today's weekly tutorial on urban services planning. So, we will, I'm unmuted, right? Yeah. Okay, great. So, I think only three people have joined so far. So, maybe we can wait for another 2 minutes and then we can start the session so that more people can join in. Okay, we can get started. So, once again, good evening and welcome to today's tutorial on urban services planning. So this today we will be discussing the content that we discussed in our video lectures for week 6, where we mainly looked into different methods of waste processing, recycling, recovery. Then we also looked into different composting methods, what are usually used, how composting is done, the different forms, what are the equipment used, what is the criteria, the planning principles. So all that we looked into detail. So this week we don't have any numericals, it's all theory based. So let's get started into each of the questions. So like always, our session would be where we would be discussing certain questions and you can we'll try answering the questions together, and then we'll discuss some content regarding those questions. And if you have any doubts, feel free to ask immediately. It would be good if you can keep your video on, and if you can speak out the question, then we can have a good discussion. Or else, if you're more comfortable in the chat box, you can put it in the chat box also. We'll discuss. So let's make it more interactive so that we can learn together. So yes, so let's get started. So the first question is, which of these is not a benefit of composting? A, reduces transportation of waste. B, reduces leachate production and treatment at landfill. B, reduces leachate production and treatment at landfill. C, does not help in recycling and incineration operations. And D, can accommodate seasonal waste fluctuations. Can someone attempt this question? Anybody? Okay, so let's go option by option. So we are talking about composting in this. So we have discussed composting is a method by which we convert the waste into fertilizer, into something which can be used for growth later. So here we are talking about which of this is not a benefit of composting. Okay, somebody has answered option A, reduces transportation of waste. It's not a benefit. Okay, so let's go option by option. So we are talking about transportation. So there are different types of the transportation. So first transportation, so we have learned about primary, secondary, tertiary transportation. So after that, we have also discussed about waste being in between. For instance, in from storage unit, waste being segregated or sorted, and after that, again being transported into landfill or different regions. So here it's not mentioned whether it's the initial transportation that we are talking about, but it's just given as overall transportation. So if we were saying that we are talking about the primary transportation, the primary waste collection system. So if that is the case, then it is from the source. So then you can say that yes, because composting is something which happens in the last end where the waste is being recycled or it's been renewed for other purposes. So then, yes, transportation may not influence. But since we're talking about overall transportation, let's talk about the situation when it is taken from the source and it's gone to the sorting center. And from the sorting center, now if we sort it properly, then we are taking some for composting. So if composting is an option available, then some goes into composting, some goes into other recycling methods, some goes into different material recovery facility, like different other facilities. So if you look at that point of view, then composting also helps in reducing transport, it reduces transportation of waste also, because yeah, exactly. That is one thing. Then we also, yes, I'm coming to that. So this is one way where we are sorting and then going. And as rightly said by Suranjana, if you're using some composting methods at our house or at a community facility, so we can have different bin composting facilities. We can have certain, within the community itself, we can have certain regions where composting is done. Yes. So if you're doing such kind of facilities, again, we do not have to transport these waste to another sorting facility or to another recovery facility. So overall, put together, transport composting reduces transportation of waste. So this is actually a correct statement, or this is a benefit of composting. Now the second comes, reduces leachate production and treatment at landfill. So again, because some is already taken for composting right now, and so this is not so the same thing, whatever was explained before. So this reduces the leachate production and treatment at landfill. So this is also a correct statement. Now comes option C, which says does not help in recycling and incineration operations. So that's not a correct statement, because of composting, the same reasoning, what the explanation, the same explanation. Because of that, we can segregate some into waste for recycling, some into incineration. So it actually helps, or it enhances the recycling opportunities and incineration operations. So this is when it says this does not help, this is a wrong statement, or it is yeah, this is a wrong statement. Now coming to D, it can accommodate seasonal waste fluctuations. So yes, composting can accommodate seasonal waste fluctuations also. So this is also a correct statement. So the which of the following is not a benefit of composting? In that comes C, does not help in recycling and incineration operations. Any doubts in this question? Okay, we'll proceed on to the next question. Yeah, so before we proceed, this is the content that we discussed in our lecture. So we broadly learned three benefits of composting and in that different points. So first one is it reduces the waste for final disposal. So that's what we were just discussing, and it increases the design life for other waste disposal facilities. So in that comes our enhances recycling, reduces pollution. Then yeah, this is one major use. It reduces methane generation at landfills because we're taking this material out for composting. So the methane generation is reduced, and methane, the problem is it gives a very bad odor. So that odor in landfill can also be controlled by using a separate composting method. Then yes, reduces leachate production, reduces surface and groundwater contamination. The second one is it allows more flexibility in terms of operation. So that's where our transportation facility, whatever we discussed, comes in over here. So it reduces transportation because we can have more decentralized operation right now. Then comes our composting can accommodate seasonal fluctuations also, because based on that we can change our method of treatment and all that. So the last one comes composting produces natural soil amendments and enhances the effectiveness of fertilizer. So this is the main use of composting, where we can use it for as a fertilizer or to improve the soil quality. So these are the different aspects which we learned in that: improves soil quality, increases biological activity. So this can be like you can combine it with different fertilizers and chemical systems and all that. So it helps to uh, it's also yeah, so it helps in reducing leachate and bioabsorption, etc. So let's go to the next question. Question 2: which of the following is a composting process using earthworms? A, aerobic composting; B, vermicomposting; C, bin composting; and D, yard waste composting. Yes, so somebody has already answered that in the chat box. B, composting. So this we have discussed. Vermicomposting is when we used earthworms in order to for composting. Then we also discussed other forms of composting. For instance, aerobic composting. So what was aerobic composting? Can somebody recollect and then say? No? Okay. So aerobic composting is when we added oxygen into in the presence of oxygen. Yes. Yes, it's right. So we will come into the details. We'll look into the slides. Then we also learned about bin composting, where in a bin it's kept in. Yeah. So let's see that in detail. So this was vermicomposting. So we discussed. So what it actually does is, because of the natural digestion process of earthworms. So earthworms, they eat this material, and then the digestion, what the digested material which comes out, so because of that the composting happens. So yes, so this is what we discussed over here. And what is the feedstock that can be used also, we discussed kitchen waste, vegetable market waste. So all this can be composted using vermicompost methods, and different worms also we discussed. Now let's look at the other process. For instance, this is the aerobic composting process. So in this, what we do is microorganisms oxidize these organic compounds into carbon dioxide nitride. Right? So we use microorganisms, and this is done in the press. So there's organic matter, there's oxygen, and then some nutrients, and because of the bacteria, now it gets converted. So this happens in the presence of oxygen. So we call it aerobic composting. And then we discussed about bin composting. So where in these bins we store this organic waste, and then we put it in different layers. So one highlight of this is that on the top layer we provide certain material like sawdust or something, so that odor is not coming out of uh, this whole bin. So this is kept like this for around 5 to 10 days, and after that, like within around 45 to 60, sorry, for 45 days to 6 months, this is the compost is generated. So this was bin composting. Then we also discussed about yard composting. So where we have okay, that's not, yeah. So where we have certain piles kept, and then in that in the yard we put this, and then we make a compost out of it. So that is also another method. So the answer to this question is Let me add someone. Yeah. So the answer to this question was that when earthworms are used, it is vermicomposting. Let's go to the next question. Problem 3. Biomethanation is an example of which of the following methods of solid waste management? A. Recycling. B. Composting. C. Waste to energy. D. At source reduction and reuse. So we are talking about biomethanation. Yeah. So any guesses for this one? C, somebody said C, waste to energy. Okay, very good. So we discussed biomethanation in detail in our lectures where we discussed that as per solid waste management rules of 2016, like all these segregated biodegradable waste must either be composted or it has to be taken to a biomethanation plant. So composting we went into the details of that, but biomethanation, the different methods of biomethanation, we did not go into details. So the answer which Shweta has put is correct. Yes, it is a waste to energy method where so biogas is generated out of these from the waste we generate biogas. So that's how we generate energy out of it. So it is a waste to energy method. So let's see that in detail. This is what we discussed. So yeah, so biomethanation is a process in which organic material is microbially using microorganisms. It's converted in under anaerobic conditions. It's converted to biogas, and then there are different processes. So it can be fermenting of bacteria, oxidizing of bacteria, or methanologic. So there are different methods that can be done. So usually there are three main groups which are usually used. Now this is what we saw in the lecture where we discussed that in the different waste to energy methods, biomethanation, RDF. So RDF we were constantly discussing overall throughout our lecture. Different material will be taken for RDF. So RDF was also a method because you're deriving fuel out of it. So, so these are different methods by which waste can be converted to energy. And this is what we learned in our SWM rules. Right. So we'll proceed on to the next question. Problem 4. Which of these areas in a compost plant receives daily waste? A. Buffer storage area. B. Buffer sorting section. C. Curing area. D. Tipping section or tipping area. Somebody says D, tipping area. Yes, very good. So let's see what each are. So we have buffer storage area. So that we've, I mean, from the words itself, we know. So it's a temporary storage area where we store before the composting or before the treatment starts. So that's a buffer storing area. Then we have the pre-sorting area where we take out all the large elements or elements which cannot be composed from the main compost thing. So it's a pre-sorting which is done. So we have learned different methods. It can be manual or it can be both mechanized sorting. Excuse me. And then we have the curing area, which is the actual pad in which we cure the compost. And then we have the tipping area. Just give me 1 second. Yeah, sorry. So then we have the tipping area. So tipping area is where the waste is tipped on, or we have discussed in the from the vehicle, it is tipped on. So that's the tipping area. So yes, somebody has answered D. Yes, so the answer is correct. It is a tipping area. So that's where daily waste. So all the daily waste comes to the tipping area. For instance, the buffer storage area, it's a store. So every day you don't, the daily waste need not be included into that, right? Or whenever a buffer storage is required, only then we would be using it. Even the sorting section, maybe every day the sorting is not being done. It can be done in an alternate days. So we discussed about 4 to 5 days. So within that duration, probably on the third day or on the fourth day, it's sorted and then it's put and then it's kept. So even the curing area, but the tipping area, since the waste is coming every day, it receives daily waste. So this we have discussed briefly over here also in the composting of feed sort. We discussed about tipping area and then we said it's a side open large shed where the vehicle comes and tips the waste onto that. So this receives daily waste. So why this is important is because it receives daily waste, we need to plan the volume of the tipping area also accordingly. based on the quantity of waste that's generated, based on how frequently this quantity is going to be taken into the buffer storage area or the sorting area, and how frequently is the composting being done, or when do we start composting. So based on that, we need to plan the volume. So this quantity has to be planned, and there should be no unregulated storage. So in this, other aspects also we learned that there should be drains to allow exit, because otherwise it can get contaminated over there, with all the waste being dumped over there. And yeah, so the pre-sorting. So this is comes the bulky item removal. So then from here it goes on to the pre-sorting this thing. So from the tipping area, the pre-sorting is done and then it's taken back. Okay, yeah. So this is tipping area is also the pre-sorting section. That's from where the uh, pre-sorting is done. Right. So with that, let's proceed on to the next question. Problem 5. Which of the following statement is incorrect about solid waste management rules? A. MRF is a facility for temporary storage of non-compostable solid municipal solid waste to facilitate segregation, sorting, and recovery of recyclables. MRF will have sufficient space for sorting and recyclable or sorting, sorry. MRF will have sufficient space for sorting of recyclable materials. C. Involvement of informal waste pickers, waste collectors for separation and collection of recyclable waste is not recommended. D. Non-biodegradable waste is transported to processing facility or MRF for secondary storage facility. So again, what is MRF? I mean, we've been discussing that all. I'm sure everybody knows the answer. Yes. Perfect, perfect. Yeah. So we are talking about the material recovery facility over here. So yes, I've seen many of you have answered it correctly. So C is the correct answer. Involvement of informal waste pickers or waste collectors from for separation. So if you say it is not recommended, then that is an incorrect statement, because it is recommended, and we've discussed this in our previous lectures also. Not just about material recovery facility when it comes to overall waste, integrated solid waste management methods, we have discussed that this is very much important, and we also have formalized it where it's made into certain systems such as kabaddi systems, where these informal who were it was an informal waste picking system until recently was taken into the formal system, where they are authorized to do this, and then for the solid waste management it is collected from these dealers also. So yes, so this is an incorrect statement. Let's look at the other statements also. For instance, the first one, MRF is a facility for temporary storage of non-compostable solid waste to facilitate segregation. Yes, that is a correct statement, because it is in the material recovery facility section where we sort out different elements. So we segregate it, and then we, yeah, based on this sorting, we take so we collect the waste from which material can be recovered, and then based on this sorting only, it can be sent to different plants or different methods by which this material can be recovered. So if the sorting is not done properly, then whatever we recover will be impure in terms of other impurities or material contaminating this overall product. So this sorting is very important, and this is the place where this temporary sorting is done. So the next option B is also related to that. So because of this, it should have sufficient space for sorting this. So all the recyclable materials need to be sorted. So this both is a correct, these are correct statements, because sorting is important and you should have adequate space for sorting also. Now comes option D, where we're talking about non-biodegradable waste is transported to processing facility or MRF or secondary storage facility. So this is also correct, like so it is non-biodegradable. So we discuss it. So if it's biodegradable, then we usually take it out for composting. And the non-biodegradable waste after sorting and segregation, that is usually transported for processing or MRF facility. So yes, so that's also a correct statement. So let's proceed on to the next question. Which of the following statements is, let me add someone. Yeah. So which of the following statements is not correct about bin composting? Statement A, compost layers at bottom prevents odor and act as inoculum. Statement B, feedstock is a mix of garden or yard waste, kitchen waste, dried waste, and paper. Statement C, regular every 5 to 10 days turning is required to prevent aerobic conditions. Statement D, time taken for compost to be ready is 45 days to 6 months as per turning schedule and waste characteristics. Okay, so somebody says A and C. Okay, yes, so it's the same answer, A and C, and A has been marked. So, I mean, option A is the answer which is said. So, let's go. First one, compost layer at the bottom prevents odor and act as inoculum. Is that a correct statement? So, many of you have already answered saying that that's an incorrect statement. So, what will be the correct statement of that? Top, okay. Composed layers at the top prevents, yes, very good. So it's, so we discussed this in when we discussed about bin composting also. So the top layer, the top layer is where we need to prevent the odors from coming out, not the bottom layer. So compost layer at the top prevents the odor. So yes, so this is an incorrect statement. Now B, feedstock is a mix of garden waste, kitchen waste, dried waste. So this, yes, it is true, we just discussed that. Now C, regular every 5 to 10 days turning is required to prevent aerobic conditions. So this also, you have said that it's wrong. So what will be the correct statement? Anaerobic conditions. Very good. Yes. So because why we turn it is so that adequate oxygen or adequate air can go in, so that anaerobic conditions are prevented. Here they're talking about aerobic conditions, so that's a wrong statement. But otherwise, this is correct. Regular turning about 5 to 10 days is required, but to prevent anaerobic condition. So yes, so this is a wrong statement. Now statement D, time taken for compost to be ready is 45 days to 6 months as per the schedule. So this we discussed, just now we discussed, so that's also correct statement. So yes, you're right. Option A is the correct answer. So let's proceed on to the next question. It's not loading, okay. Yeah. Problem 7. Which of the following is used to determine nature of different materials in air classification facilities? A, temperature sensor, B, optical sensor, C, piezo sensor, and D, position sensor. Any guesses? B, optical sensor. Yes, so it is by using optical sensor. Very good. It's by using optical sensor that we use in air classification. So in air classification, we are not taking temperature. So again, temperature sensor is piezo. Piezo is again related to pressure or weight being applied on something. So that's also not used. And position is also not used. So the answer to this is optical sensor. So using optical sensor in the air classifier, we classify that. So that's the method which is used. So this is what we discussed in air classification. We discussed about different air classifiers, and then we came into how do we detect and route systems. So we, in that we discussed that optical sensors are what are used in order to determine the nature of different materials. So for instance, paper, plastics, and all, they have different nature. So it is using optical sensor that it is tested. Okay. So let's go to the next question. Problem 8. Which of the following is correct about pre-sorting in mechanized material recovery facilities? Statement A, removal of bulky materials. Statement B, separation of particles into different size. So we are talking about pre-sorting again, just to highlight, we are talking about pre-sorting. Statement B, separation of particles into different size distributions. Statement C, shredding of waste. And statement D, initial manual sorting. So option yes, two people have said option C. So which means option A and D are correct is what you're saying. Okay, so let's look at different ones. So first one, removal of bulky materials. So in the pre-sorting, removal, so which of the following statement is correct? So is removal of bulky material, A and D, A and D is, somebody says A and D is correct. Okay. Um Yeah. So removal of bulky materials, yes. Now separation of particles into different size distributions. Is that done in pre-sorting? No, A and D, which is option C. Yeah. So all of you are saying A and D, A and D. Yes. So yeah. So separation into different size distribution is not done. Shredding of waste is also not done in pre-sorting. Because pre-sorting, we are just taking the initial the pre-sorting one. So yeah, and the initial manual sorting that also happens. So yes, this is the correct statement. A and D is the correct statement. Yeah, that's an easy question. So yeah, let's go to the next question then. Problem 9. Which of the following is not a benefit of turning the content of windrow composting? A. Oxygenates the pile. B. Breaks the particles into increased surface area. C. Improves the porosity to prevent settling and compaction. D. Prevents heat, water vapor, and gases to escape. So yeah. So C, D, D, D prevents. Okay, which of the following is not a benefit? Okay, so first one, oxygenates the pile. Yes, definitely, it oxygenates the pile. Breaks up particles to increase the surface area. Yes, because when we keep turning, we break up the particle. That's also correct. Improves the porosity. Yes, that's also there because we are allowing more air into. Last one, prevents heat. So we are talking about prevents heat and water vapor. Yes, so all of you are right. Yes, that's a wrong statement because it actually enhances the escape of heat and water vapor and gases outside. Right. So very good. So uh, somebody says generates heat. Um, no, here we are talking about the escape of heat and water vapor, which is already there. So during the composting process, yes, some amount of heat, some amount of chemicals are emitted out. For instance, methane formation and all are there. So when we are turning it like that, it allows it to escape outside. So that allow is the keyword over here. Right. Let's go to the next. Oopsie. Yeah, let's go to the next question. Match the following stages and their description with respect to microorganisms in composting. So, different levels of composting is given. So, this we have mesophilic stage, thermophilic stage, and curing stage. So, we have discussed there are three stages in general. So, these stages are given in a jumbled up order, and then we need to say which matches which. Okay, let's come to the answer. So I'll just read the description also. So description one, screening of decomposed mass and then allowed to mature. Two, compost becomes dark brown and gradually stabilizes. And three, decomposition of easily degradable organic matter, intense metabolic activity. So yes, so all of you have answered C. So let's go by, so A, what does A match to? A match to, if it's as per C, then A matches to 2, I think. Compose becomes dark brown. Then, okay, before we go into this, I think it would be easy. Can we give the order in which, what is the first stage, what's the second stage, and what's the third stage? First stage from A, B, and C, what is the first stage? Is it mesophilic? Is it thermophilic? Is it the curing stage? Thermophilic, yeah, very good. So, first one is the thermophilic stage. And what happens? So this is in this stage, all the easily decomposable materials are so degradable materials are easily so all the easily materials are taken off. And then the second stage is which is no first yeah second stage is the mesophilic stage. Yes, correct. Second is meso. So what in that again more decomposition is happening. So you have the dark brown formation happens in this meso stage. So let's take that as the keyword over here. Now, in the third stage, that's the curing stage, where the compost becomes more mature. So that's the last stage. So it becomes more mature. Excuse me. Now let's try to answer this question. So coming on, yes, you're right. Mesophilic stage, the compost becomes dark brown. So yes, that's the correct answer. Then the thermophilic stage, which is our first stage, where it's the easy. So here decomposition of easily degradable organic matter and there's intense metabolic activity over there because yeah that's the first stage. So when you start initial stage itself. So yes, so that's also right if you look at C, it is B3. Then curing stage, that's when it's allowed to settle down. So the screening happens and then it's allowed to settle and mature. So that's the last curing stage. So very good. Yes, C is the right answer. So let's go to the next. Before we go, I think I have, yeah. So this is what we discussed. So in composting using microorganisms, so we have the first, second, and third. So these are the different stages. Now, mainly they are separated based on the temperature difference, if you look. So, or the moisture content also. So here the temperature, it's about from 35 to 55 to 65 degrees Celsius. So there's certain increase in temperature because of all the activity, the composting happening. So as rightly pointed out in one of the previous questions, somebody mentioned that it generates heat. So yes, so the increase in temperature happens in this stage, in the first stage. And then we're coming on to the mesophilic stage, where now the activity is again reduced, and then the temperature is also reduced, and then other microbacteria becomes active, and the compost becomes brought down, and then we have the curing stage. Okay, so let's proceed on to the next question. Problem 11. Which of the following statement is true with respect to composting? Statement A. Limited oxygen supply slows down the composting process, resulting in anaerobic conditions and odors. Statement B. Decomposition rate of compost is 10 to 20 times faster in anaerobic conditions. Statement C. Providing forced aeration maintains anaerobic conditions for composting. Statement D. Consumption of oxygen is more during the early stages and gradually decreases. Okay, so option A and D is correct, and C is the correct answer. Okay, so let's see. First one, limited oxygen supply slows down composting, results in aerobic, results in anaerobic condition. Yes, so if oxygen is limited, it results in anaerobic condition. So yes, so that is yeah, so that's a correct statement. Then we have decomposition rate of compost is 10 to 20 times faster in anaerobic conditions. So we are talking about anaerobic conditions. So that is not a correct statement. So not a correct statement. Then we have statement C, providing forced aeration maintains anaerobic condition for composting. So again, that's also it. If you give forced aeration, it gives aerobic conditions. Yes, as rightly put in the chat box. Yes, it gives aerobic conditions. So that's again a wrong statement. And now deconsumption of oxygen is more during the early stages and gradually decreases. So that again we discussed in the different forms. So it is in the first stage where you have maximum activity. And in the second stage, again, the consumption of oxygen or the activities, aerobic activities reduces. So that's when you get the dark brown also. So yes, so this is a correct statement. So yes, correct answer. A and D are correct statements, and that works out to option C also. Yeah. So let's proceed on to the next question. Problem 12. Match the following stages with their description about windrow composting. So different stages, two-stage screening, pre-processing, curing, compost refinement. Now description, maturation and moisture control of compost, air density separator to remove sand, grit from compost, 35 millimeter screen rejects from that are sent to RDF facility, and 16 millimeter screen rejects are sent back to windrows as protective cover. And fourth one, separation and removal of oversized non-compostable material. So first one, yeah. So first one, I think somebody has option D, option D. Okay, all of you have answered option D. Okay, so it seems like everybody knows the answer. So let's quickly go through that. I don't think much explanation is needed if that's the case. So first one, two-stage screening. Yeah, so that is easy because we are talking about two-stage screening, and there's no other option which talks about screening. So yeah, so it is 35 millimeters. It is sent to RDF facility. So we learned RDF is where we generate fuel, and then the 16 millimeter ridges are sent back to the windows as a protect. So we learned in the top layer we need protective coating to avoid odors and all that. So this one, because it's again fine, it's a 16 millimeter reject, so that's again taken. So that's correct. Now B, pre-processing, yes, we've discussed that that's when we remove off the oversized materials and all that. So yes, that is fourth, separation on removal of oversized material. Now C, curing, that's when we do the moisture control. So maturation and moisture control and curing, just the previous question we discussed. Then we have compost refinement, where in the last one, density separator is used in order to remove the sand and then refine the compost. So yes, so very good. Option D is the answer. So let's proceed on to the next question. Before that, this is windrow composting, what we discussed, where we in different piles we keep these compost, and then it's kept for maturation. And then we have a slope. It's usually sloped this way in order to facilitate leachate and all that. So I'm not going into the details because most of you answered the question correctly. So yeah, so these are the different stages again which we discuss. So we just discussed this. So yes, so let's proceed on to the next question. Problem 13. Which of the following statement or statements are true with respect to box composting? Statement A, gaps between bricks and box wall for leachate collection. Statement B, waste mixed with straw to allow passive aeration. Statement C, slope provided at base for leachate collection channels. Statement D, base of box is made up of PVC, metal pipe, network considering incumbent load. So is option yes. So you can answer this question and then we'll go. Or first one, statement A, gaps between bricks at there are gaps between bricks of the box wall for leachate collection. Is that a correct statement? Is it for leachate collection that we have gaps between the bricks in the box? So somebody says option D. Option D, statement B and C are correct. Okay, so if that's the case, then statement A is wrong. So yes, yes, correct. So Ranjana has put it. So that gap is mainly given for aeration purposes. It's not to collect the leachate. For leachate collection, we have different slopes which are provided, which takes out. So that is a wrong statement. Then we have option B, waste is mixed with straw to allow passive aeration. That is a correct statement because it's light. Straw is lightweight. It allows more air to come in. So waste is mixed with straw to allow passive aeration. So yes, that's a correct statement. Now statement C. Uh, yeah, statement C. Slope provided at base of leachate. Yeah, so this is what we discussed. Slope provided at base for leachate collection. Yes, so that's also a correct statement. And now we have statement D. Base of the box is made up of PVC metal pipe network considering incumbent load. So if it is option D, which means statement D is also wrong. So what is the correct statement then? Somebody says B and C are correct. Yeah, so B and C are correct. Okay. Agreed that B and C are correct. So if statement D is wrong, what is the correct statement for D? How do we correct this statement? No, okay. So going back, side of the box, base of the box is made up of PVC, metal pipe, networking. Okay, so you're saying that it should have been side of the box, considering incumbent. No. Anybody? Any other answers? Okay, us yes, but we also have this PVC metal pipe network running through the base of the pipe base. It's okay. So yes, I think sir is rightly said. If you're considering the incumbent load, then it is RCC and PCC which plays the it is the based on the load we design the RCC layer which needs to be there, and on top we give the PCC layer. But so that's why. So the statement here is if you're considering incumbent, if you're talking about incumbent load, then this is like the PVC metal pipe is not. But we PVC or metal pipe, but we have these pipes in order to collect this one for the drainage or for aeration purposes. Sometimes is pipe is also given. So we discussed we can have PVC pipes through which air is passed, and because of this aeration is done. So this is pipes are given that type of design is also there, but then it is not because it is not to what do you say, consider the incumbent load, but it is done for aeration purposes or drainage purposes for something else. Yes, so Ranjana has correctly put in the chat box. It is for waterproofing or drainage. Waterproofing, no, but mainly for drainage facilities or aeration facilities. Yes, 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 correctly put in the chat box. Base of the box is perforated to facilitate aeration and drainage. Yes, that is the answer. Okay, so that's why the statement is wrong. So just to come back, if we had just given the statement without saying considering incumbent load, the statement, I mean, the question would be a bit difficult to answer in that case. It would be a bit ambiguous, but then we cannot say that it is a wrong statement because it is it is given, right? So that one, yeah. So the answer was correctly answered. Statement B and C are the correct statements. Now let's proceed on to the next question. Problem 14. Match the following about various MRF facilities and equipment. First one, air classifier. Two, non-ferrous metal separation. Three, size reduction. Four, ferrous metal separation. Now the different equipments: eddy current separators, magnetic belts, use of high velocity airstream, and hammer mill. So yes, so I think, yeah, so can we answer this? So first one, air classification. Which of the following is air classification, the equipment? That was pretty straightforward. Use of high velocity airstream, it's given. So I think first one is easy to do. Now second one, B, non-ferrous metal separation. That's also easy because we are talking about, okay, non-ferrous metal separation. Yes, what is the answer? Ferrous is easy. Non-ferrous is option D for this one. Someone's put option D. Is that for this question that you're answering? Yeah, so yes, eddy current separator. So in eddy current separator, what do we mainly do? So all this aluminum materials which has aluminum content and all that can be easily separated using eddy current separator. So there's an electromagnetic flux which is generated, and based on this stream, these metals are separated. So that's the non-ferrous metal separation which is used. Yes, so that is eddy current separator. Now we have size reduction. Which would that be? I think from the answer options, yes. So we are talking about hammerel. So hammerel, yes, correct. So it is hammerel. So what hammer mill, what hammer mill mainly does is it's kind of a shredder. So it shreds and it reduces. So that's what we've discussed this. We've seen an image also in our lectures on how this works. Now finally we have the ferrous separator, where we use a magnetic belt and then separates. So which, yeah, so correct, it works out to option D. I think somebody had already mentioned that it works out to option D. So yeah, so this is the explanation for that. I think my slides are not changing. Yeah. So yeah, so in air classification, we make use of different air in order to separate light and heavy materials. So that's what's done. And in the non-ferrous, yeah, so this is the eddy current separator, where helps in separation by ejection of aluminum and other materials from a moving stream by a force of electromagnetic flux. So that's how the eddy current separator works. And hammer mill is a shredder. And then we have the ferrous. So this is the explanation for that. Let's go to the next question. Problem 15. Okay, I'm sorry, my slides are not loading. I think there's a network issue. Yeah, problem 15. Okay, sorry, I came and then it went. Yeah, problem 15. Choose a correct sequence from the most to the least preferred solid waste management practices. So first one, at source reduction and reuse, recycling, followed by composting, followed by waste to energy, and the last is landfill. B, first is at source reduction reuse, recycling, composting, landfills, and then waste to energy. Then C, composting, source to reduction, recycling, waste to energy, and then landfills. And D, at source reduction, composting, recycling, waste to energy, and finally landfills. So yes, so somebody has answered A. Yeah, so A is the correct answer. So first we reduce at the source, reduce, reuse. So we have learned the three R's. So that comes over here: reduce, reuse, and recycling. So that's the first one. Then composting, and then waste to energy, and finally it goes to the landfill. So this is the correct sequence. So landfills will not come before waste to energy, because if we can generate energy out of it, that's better. So waste, it comes before that. And composting, again, the first will definitely be source reduction. So yeah, so this is the answer of that. Right, let's proceed on to the, yeah, so this is what we discussed. This is there in the CPHEO manual, uh, the, the most preferred to the least preferred. Let's go to the next question. Match the following concerning different solid waste management practices. P, recycling. Okay, so the different ones are recycling, composting, and waste to energy. So this we have already discussed in some of the questions, so we'll quickly go through this. So first one, conversion of biodegradable waste to fertilizer. Second, recovery of commercially valuable materials. And third one, energy recovery from waste. So A, yes, some A. Yeah, so first one, recycling is, yeah, so I think this is a very, very easy question. So first one, recycling means your again recovery of commercially valuable materials, composting, conversion of biodegradable and waste to energies, converting. So let's go to the next question. Identify the true statements concerning material recovery facility. A, depends on the scale of operation. B, separation processing is done for compostable matter and recyclable materials. C, depends on level of mechanization. D, residual inert waste which cannot be recycled is sent for landfill. So any guesses on this? Is A for this question? The answer, okay. So first one, it depends on the scale of operation. Yes, so the material recovery facility needs to be designed based on the scale of operation. So yes, that's the correct statement. Now option B, or the statement B, separate processing is done for compostable matter and recyclable materials. Yes, this also we have discussed. Separate processing is done, so that's also a correct statement. Statement D, C, depends on level of mechanization. That's also correct, because what method we are using, it depends upon that. And then D, residual inert waste which cannot be recycled is sent for landfilling. So yes, so with all this put together, yes, Shweta is right. Option A is the correct answer, all of the above. Let's go to the next question. Identify the process employed in material recovery facility. A, removal of contaminants. B, baling. And C, flattening. So removal of contaminants, yes, that is there. We've discussed it in material recovery facility. We remove contaminants, so that's there. B, baling. What is baling? Excuse me. So it's something where you group different, yeah, exactly. So you tie them up or you group them up together or you compact them up together, and then you do the recovery facility. So this is usually done. So flattening is again uh, you flatten it out. So yeah, so baling and flattening is done in order to compact. So this is also part of a material recovery facility where you take the material, you compact it and make it out. So yeah, so option A is the correct answer. All of them are involved in the material recovery facility. Let's proceed on to the, yeah, so this is what we discussed. Sorry, in the material recovery facility. So we role in the main role of the facility is to remove contaminants, baling, flattening, or crushing of material. Let's proceed on to the next question. The below figure represents which of the following? A, vibratory flatbed screen. B, disc screen. And C, trommel. And D, hammer mill. C, trommel. Yeah. So we've discussed this. So this is a trommel into which into which so again, what's a trommel used for? What's it used for? Sorting, screening? Yes. Very good. Yeah. Correct. Correct. Very good. So yeah, so we have learned different ways of sorting. So we have manual sorting, and then this is a mechanized sorting method. So we use a trommel in order to sort mechanized. So we have these back ends over here, uh, in which what do you say? Different materials are extracted. So there are uh, different processes which are happening inside. So based on the weight of the materials, based on their magnetic properties. So we've discussed these different techniques which are used. So all these are put into this. So trommel is an equipment or a system which is used in order to sort these materials, or to do the pre-sorting, which is done. Right. So yeah, so this what is shown over here is trommel. We also learned about hammer mill, which looks something like this. So in the previous question, I said we have discussed this, so I thought I'll put this. Sorry. Yeah, correct. It's a shredding machine. So in the previous one, we discussed what is used in order to reduce the size of particles. So that's why we discussed it's a hammer mill. So over here, so usually what happens is we get confused between a trommel and a hammer mill. So that's why I put these questions together. So this is a trommel. What we see over here, sorry, in the previous slide, the slide didn't change. One sec. Uh, yeah. So this is the trommel, and what you see in the blue over here, this is a hammer mill, which is used to shred. Right. So let's proceed on to the next question. Problem 9. Dash classifies as per aerodynamic characteristics. A. Air classifier. B. Electromagnetic classifier. C. Disc screen. D. Trommel. That's again a very easy question. Air classifier, because we are talking about aerodynamic properties, which means we're talking about based on the waste we need to classify. So that is an air classifier. Let's proceed on to the next question. Dash involves separation by ejection of aluminium and other metals from a moving waste stream by a force exerted by electromagnetic flux generated. A. Eddy current separator. B. Rotating disc separator. C. Disc screen. And D. Trommel screen. Yes, it is eddy current separator. We have already discussed this. So it's just given in a different form. The whole question, it's been rephrased in a different form. So very good that you're being able to recollect and answer it. So let's proceed on to the next question. Match the following concerning mechanized material recovery facilities and processes. So the different processes and the descriptions are given. So first one, P. Trommel screening, Q. Ferrous metal separation, and R. Rotating disc separator. So description is 1. Tumbling action by rotating screen results in efficient separation. 2. Magnetic belts attract the magnetic particles and carry them on the belt surface while non-magnetic particles fall away. And 3. Primarily used in separation of inorganic materials from refuse derived fuel RDF fractions. So yes, so first one probably. Answer is A. Okay, very good. Answer is A. Yes. So let's go. First one, the trommel screening. That comes to it's there. The tumbling action by rotating screen results in efficient separation. We just saw the trommel, so we know that's the answer. Yes, good. Ferrous metal separator, magnetic bolts are given. Yes, so it's all matching. So then rotating disc separator, the primary. So yes, so the answer is A. Very good. So let's proceed on to the next question. Composting is dash a process of controlled decomposition of organic waste, typically in aerobic conditions, resulting in the production of stable humus-like product. B, a process of controlled decomposition of inorganic waste. Rest everything is the same. Not reading it. C, a process of controlled decomposition of organic waste, typically in anaerobic conditions, resulting in production of stable humus-like product. And D, a process of controlled decomposition of inorganic waste, typically in aerobic conditions, resulting in a production of stable humus-like product. So controlled or yeah, yes. Somebody was answering it. There's only one answer correct. A process. Okay, very good. Yeah, that's a correct answer. So as rightly put in the chat box, it should be a controlled environment. Yeah, it is a controlled decomposition, aerobic condition, and we are using organic waste for that. So all this, so it is not the same. Read it once more. Read it once more. Hmm. It is anaerobic. Okay, that's where the catch is. So usually we might feel that we might overlook these things. So yeah, so this is anaerobic condition. So that's why I really liked how the question was answered in the chat box, where it's put that it is controlled, organic, and aerobic. Yes, these are the keywords also, that it's controlled decomposition and it's organic waste, and it preferably it should have aerobic conditions. Right. So yeah, let's proceed on to the next question. Identify the true statements concerning material recovery facility. Several questions we have seen along the same in the same pattern. So first one is depends on the scale. I think we already answered this question. Depends on, yeah, we already answered this question. Yeah, so let's proceed on to the next question. Yeah. Match the following concerning composting. So you're talking about moisture content over here. Below 40 percentage and Q is above 65 percentage. Description restricts air movement through pores and results in anaerobic condition. Excess leachate may also be produced. And 3 slows the composting process. So yeah, let's see. P below, so we are mainly talking about below 40 percentage and above 65 percentage. So it's like either side, not the optimal condition, something below and something above. So if it is below 40 percentage, what happens? Very good. Yeah, it will then because you don't have much, so it is a slow composting process which happens. If it is above 65 percentage, what happens? When there's more air. Okay, yes. So more is being supplied. Yes. Is that the only thing which happens? Excess leachate may also be produced. Yeah, yeah. So now it's because of this again, because of the excessive composting which is happening. The pores can get clogged, and because of this, air movement can be disturbed. So if that happens and aerobic conditions happen, what do we generally do in order to avoid this? Yeah, we maintain the moisture content adequately, and also in certain cases we can, so if this restricts, if the pores get clogged, we can also do an turning. So that's why all this turning is done every 5 to 6 days. Yeah, exactly. So one another method is you use certain light materials such as sawdust or leaves in order to absorb. So that's also used. Also, we by manual turning also we can avoid this if because of excessive so when you do that, we can get it out because it gets mixed with all these other materials which are there, right? So yes. So which option does this work out to? P is 3 and Q and yeah. So option A. Right. Let's go to the next. Yeah. So this is what we discussed in the lecture. So if it is low, that's also a problem. If it is high, that's also a problem. So preferably about 50 to 60 percentage is the moisture content that we usually maintain. That's what it needs to be maintained. Let's go to the next question. Which of the following factors influence the composting process? A. Moisture content. B. Particle size. C. Feedstock composition. And D. Temperature. And E, all of the above. All of the above, yeah. So this is a very straightforward question. Composting process, all of the above. So let's go to the next question. A general rule of thumb for pathogen suppression is to maintain the composting process at dash degree Celsius for 3 consecutive days. 35 to 45, 45 to 55, 55 to 65, 65 to 75. So Shweta says C, 55 to 65. Yeah, very good. That is the answer. So this is again a general rule of thumb which we have learned. So in the previous one also we yeah. So the temperature is usually maintained in this 55 to 65 in order to suppress pathogen. Yeah. So right. Let's go to the next question. This is something which you can just answer by looking at this question. I mean, it's related to the content that we have discussed, but uh, the question more or less wants you to apply your mind and then answer the question. So pick the correct statement based on the graph. So the graph has time in one axis and then pH on the time in the x-axis and pH on the y-axis. So A, the pH level of mass varies with time. B, the pH level drops initially due to synthesis of organic acids. These serve as substrates for next group of microbial species. C, pH levels rise again when the acids are consumed by microbes. Okay, option A, all of them. Yes, very good. So first one, why I'm saying this is that you need to apply your mind is even if you didn't learn anything about composting, just by looking at the graph itself, we'll be able to answer this question. So first one, the pH level of the mass varies with time. That is true. There is a variation which is there, so that's a correct statement. Now, first one, pH level initially drops due to synthesis of organic acid. So yes, it is dropping. It is dropping. And why it's dropping? It's because of the synthesis of organic acids that we have discussed in the initial phase of composting. There's a lot of organic acids which are being generated. So the pH level drops because of this. And these serve as substrates for the next group of microbial species. Now C, pH level again rise when the acids are consumed by microbes. So this is the process which is shown. So it's correctly described over here. So the answer is all of the above. Okay, let's proceed on to the next question. Which of the following composting methods is the in, in, in which of the following composting methods is the feedstock kept enclosed in a chamber or vessel that provides adequate mixing, aeration, and compost and moisture? A. In vessel composting, windrow composting, yard composting, aerated stack pile composting. Option A, vessel composting. Yes, so it's right from the question. The description of vessel composting is given over here. The other ones, windrow composting, we saw we have different in a big region. We have different piles or different sets of compost which are kept, and then it we do. So that's a so we saw a figure like this. Yeah, that was windrow composting. And then we have yard composting, which is done in a yard, and then we have aerated stack pile composting, which we have seen that we use some pipes or something, and then we aerate the composting process. Sorry, the whole compost. We provide air using certain pipes. So that's an aerated stack pile composting. So here we are talking about vessel composting. Question 30. Dash involves forced aeration using a network of perforated pipes. Same thing, vermicomposting, windrow composting, yard composting, aerated stack pile composting. Which is the answer? Very easy. D, yeah, aerated stack pile composting. Okay, so we've discussed 30 questions today. I think that's all that can be discussed from this. So that's all the questions that we I wanted to discuss today. If you have any doubts regarding any content regarding week 6, you can ask right now. Yeah, yeah, Shweta. Yes, you're audible. Oh, sorry. I had muted myself. I'm sorry. Yes, Shweta, you're audible. Yes. So the final exam will be very much similar to the assignments that we are discussing. Okay, someone wants to join. Yeah. Yeah. So it'll be very much similar to the assignment pattern itself. Will have multiple choice questions. You'll have to answer them. Some numericals will be there, not a lot. Whatever numericals which we have discussed in class, only those type of numericals will be there. And again, everything will have options. So from each module, you can expect at least two to three questions from each module. So the distribution would be very much uniform. It won't be concentrated anywhere. It'll be asked from uh, everything. It will be MCQ questions. Yeah, it'll be MCQ questions. Right. Yeah. Yeah. So it will be only one option correct questions. Multiple answer. Okay, multiple option correct questions. Even if they're coming, they will be in the format how we have discussed in the class. For instance, A, B, C, D will be there, and then in the options will be there as A and B are correct, A, B, C, D and correct. So like that, another set of options will be given. So eventually, it will be like only one option correct. That would be the format. Okay. Any other doubts? Any? So I hope all of you have registered for the exam, right? You missed registering for the exam. Oh no. Is it closed? Okay, okay. Why don't you mail NPTL once? Because again, this is again not within our scope, like from the. It should be because as of now, anyway, the exams, I don't, they have not prepared a schedule, they have not given the hall ticket numbers and all that. So if you mail immediately, it should be possible. Don't, yeah, yeah, you see, you mail NPTL with a CC to Professor Devapratham Pandit so that sir can also vouch for you in case. Yeah, you can put like the you can put me also in CC because I know that you have been attending all the live sessions since the first class. So yeah, so with that, yeah, you can put us in CC and then you can mail. So we'll also request NPTL whether it can be considered. My mail ID, yeah, so I can just drop my mail ID over here, jeslu at iitkgp.ac.in. Yeah, so I've dropped my email ID. Do you have Professor Pandit's email ID? I think that should be there in the website, right? Or do you want that? Yep, 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 yeah, I can give you right away. Uh, yeah, so let me just type it. Yeah, but the main mail has to be sent to NPTL team because they are the ones who conduct the exams. We have very limited role in all the organizations. So the system, let's say. Yeah. Okay. So any other doubts, anybody? Okay. Yeah, so if that's the case, we can call it a day and end today's session. So thank you all for joining. I'll be around for another 10, 20, half an hour. Like it's only 8 o'clock. So I'll be there for another half an hour. If you have any doubts, you can always log in back and then ask your doubt. Okay. Yeah. Thank you. Thank you all.
हाँ सर ব্রেকের প্রবলেম হচ্ছে আচ্ছা ঠিক আছে ঠিক আছে
Awesome.